Good afternoon, everyone. Welcome to Dreamforce. Thank you very much for taking your time to be here to learn about the integration and how you can do an asynchronization trigger to have an real-time integration data. Um, I assume the clicker should work, but let me try. All right. My name is Prag. I'm an Salesforce MVP, and I'm also a founder and CEO of a company called Skill Cohort. We are primarily focused on solving security problems for our customers. So if you have any problems or scenarios where you want to talk about data classification, access management, data security, we are the ones who are definitely pioneered on it. I want to apologize because my friend, who is Karan Raj, who is supposed to be joining us, but because of some personal reasons, he couldn't join us. But he has put down a lot of work to make this session a real thing for all of us. So I know the topic is more on asynchronous triggers for change data capture, but still I want to take a quick moment to brush up our thoughts and understandings about change data capture. What is change data capture? And sometimes it's been also called as CDC. So what CDC is in Salesforce out-of-box functionality. You don't have to build a complex solution to track it. It's actually built on an event-driven architecture, and what it does is it actually monitors the changes that happens within your Salesforce records for the objects that you enable change data capture. And when it happens, there is a change message that will be created and actually published in an event bus, and everything comes out of box functionality. Then let's start with a customer story. So here, this example is we are working with one of the financial institution. Of course, it's a bank, so that's why we couldn't able to disclose what bank it is. But they started using Salesforce as their primary core of their business. But of course, most of you know, and even there was a comment in the keynote today that there are still people who are using mainframe systems. There are like systems that's like very, very old. But at the same time, with the transformation happening on the technology side, people also want to acquire and add more systems as part of their day-to-day access. So for that, all they wanted to do it is they want to keep on integrating more systems with their core Salesforce platform, and they are particularly clear that they cannot able to keep any system down as part of any of these integrations. So this is the scenario, and how we would have handled it if we go through a traditional trigger would be like you create a trigger and then you try to connect it with third-party systems by making Apex callouts. And some of the challenges that comes with that methodology is you cannot able to scale, which is the primary scenario for it. Then the second one is you easily hit the governor limits, because when you are dealing with massive volume of records, that's one of the biggest governor limits you always hit. Number three, which is like increase the payload time. So when you have multiple systems that are connected, and if you're trying to pass live data, then there's going to be a huge resource consumption as part of the transaction. And number four, it actually goes through a sequential order. So whenever anything goes through a sequential order within the Apex transaction, if there is a breakage happens, then everything comes after is going to be stopped and going to be rolled back. So this is how we used to do it using traditional triggers. But with the help of asynchronous triggers, what it allows us to do is you can able to create a very similar functionality on the CDC enabled objects, which means the biggest difference is using the traditional trigger, you will be building an automation on top of the transactional tables. But when it comes to asynchronous, that you build it on CDC objects, the transaction is already completed and it's committed, and once it got committed, the message got published, and then you are taking the information out of this message, and then you are proceeding with your automation process. So this is the biggest difference from an architectural standpoint. That gives you the flexibility of going through all the challenges that you have gone through using traditional triggers. Some of the advantages I wanted to highlight is to start with, every CDC trigger will be subscribed to the event bus, which means if you have multiple systems that you are connecting with your Salesforce core application, you don't have to use the same trigger. You can actually use individual triggers for individual integrations. So it's easy for you to either scale one of those integration, or if you want to decommission any of those integrations, you don't have to go through a huge process of going through multiple approvals because you're going to touch it, the primary core of your traditional triggers. But in this way, you are actually segmenting it into individual triggers, so you have more flexibility around it. Then number two, it actually runs on an independent execution cycle, which means all the governor limits that you think of you will be hitting, it actually makes into n number of times the triggers that you are creating on those CDC objects. Number three, it ensures transaction integrity even in the case of trigger errors, which means if there is something happened on the CDC event level, then you have an option to recall it and could be able to process the messages that get lost as part of the transaction. And the last one, as I mentioned, it also goes through its own governor limits. Oh, yeah. So a quick snapshot of how your context would look like when you are trying to create it as part of your trigger at new is when you see this context, there is a specific section where I want you to focus, which is it actually comes with a change event handler. And within the change event handler, you have a specific option that you can able to extract, which is the change type. And this is all it primarily matters to you, because every single message that get published in the event bus will come with either and create or update or delete or undelete, and based on that you could able to create your asynchronous triggers, and you could able to capture those differences and could able to do different set of actions. So I know talking is kind of boring. So I have a very simple demo I would like to show you folks. And if the internet didn't help me, I have a decent version of recording of it. So please excuse me if we couldn't able to catch up with the flow. So what I did is I actually logged into one of the developer environment. And what we are trying to do is every time when a record on the account object gets created, it's actually sending signals to two different systems, two different third-party applications. And we're going to see if we're going to perform the same thing using regular triggers versus asynchronous triggers, what are all the differences we could able to identify under governor limits. To start with, for an easy labeling standpoint, under accounts, I'm going to create a new record and I'm going to call it as regular triggers. And I click save. So these are all the two endpoint systems that we have configured just for the purpose of demo. And if I go here, if I see, oops, sorry. I actually got that response. It actually come here as like a regular trigger for the SAP system. And if I also go to an account management, I have another request that comes to regular trigger. That is like pretty simple. But the difference we could able to identify is if you go to debug logs and do a quick check. And if I go to this, if I go down and if I see the number of future calls it took was 2 out of 50, because like two different systems that I'm trying to send the same information. Okay, this is how we all know how to do integrations for in third-party systems if we have multiple systems. But let me quickly go through a very similar demo, but in this case we're going to make a small tweak, which is ASY ASN triggers. And for the demo purpose, we have this checkbox, which means we handled it at the back end on the coding side so that we ignore if the checkbox is checked to go through the traditional triggers and go through the asynchronous triggers. Again, purely for the demo purpose. Now, if I click save, I go here to a refresh. Now I see, yes, I actually received the record, which is asynchronous trigger, both on SAP management system. And also, if I go to accounts, I also get it on the account management system. But the difference now is, let me go back to debug logs. Let me refresh it. And now I see there is like an n number of debug logs that gets created. And if you notice, there are two different kinds of debug logs that get created. One is on the user mode, which is my username, and the other one is an automated process. So let's take a quick look about those two differences and what it happens. So if I open this and this, open this. So these are all the debug logs for the asynchronous triggers that I created as separate triggers, which I will quickly show you. But if you see here, if you go to the governor limits under future calls, it actually consumed only 1 out of 50. And that's a very similar experience you will get it for the second asynchronous trigger we created to achieve the same request. And if you see here, the number of future calls is also 1 by 10. But the difference is I also opened the debug log for my personal use, and here it will easily show that it's been excluded and the future calls are 0 out of 50. Okay, so what's going on at the back is to achieve any of these, as I mentioned, you need to have CDC enabled in your Salesforce org. So to do that, you have to go to settings and you have to search for change data capture. And when you open it, you have all the list of objects. And when you're trying to enable change data capture, you have like most of the standard objects and all of the custom objects you can enable. And once you select it, add it, make sure you have to click save. Okay, don't get into the rabbit hole of I did it, but I couldn't able to see it. It's because you have to click save explicitly on that. But once you do that, what happens behind the scene is there is a separate event object that gets created and associated with the account object. And what happens after that is now you have the flexibility of creating a trigger for that dedicated object. And of course, everybody, I assume, have gone through a Visual Studio Code at some point in time. So if you see here, what we have done is we just created a very simple trigger on the account object. And all we do it is we are actually set those two endpoints under a class and we call those methods here. That's all we did using the traditional triggers. But when it comes to the change data capture triggers, you could able to see that the S object itself is different, and that's been created by Salesforce, and we did not do any of those things. So when we do that, look at this, as I mentioned about the change event, which was highlighted under the trigger context, that you could able to capture it, either create or update or delete. You could able to use this single trigger to capture all of those different updates, and that could able to handle everything related to that particular integration with the third-party system. And what we did is we also did the very similar thing, and we have gone through it and we called it. And I also mentioned one of the highlight is you don't have to worry about any of the errors that happened, because of course, if you know platform events, that is the benefit that you could able to go back and resume the checkpoint and could able to achieve all the errored ones, and you can able to re-trigger it without troubling any of your end users. So as I mentioned, we created two triggers. One is for the account management system, and the other one is for SAP management system. It's almost the same. We just change the name, and also we change the endpoint URL. But in a real life scenario, what you will be doing is you will be imposing almost all the complex business logics you have to put through as part of these triggering events, and then you will actually send those informations to it. Okay, that's about the demo I have, but I will quickly go back and I want to quickly walk through some of the rest of the slides. Okay, so let's take a moment to see the quick comparison between some of those aspects and what is the difference in terms of regular triggers and asynchronous triggers. To start with, from a trigger execution standpoint, the first one is purely based on all the DML operations. Okay, but using asynchronous triggers, it's purely based on the CDC event messages, which means you don't have to rely on the transactional data tables for doing any of these actions. Then number two, transactional separation. Using regular triggers, everything falls under the single transaction, but the second one, each and every individual integrations would be considered as a separate transaction. Number three, from an user experience standpoint, depends on how complex the system is. It's going to make a tiny little difference from a page loading time standpoint when you're using regular triggers, but when it comes to asynchronous triggers, there is no way you will be able to see it. Number four, which is the transactional commit sequence. From a regular triggers, it actually, the automation kicks in before the record gets committed. But when it comes to asynchronous trigger, that should be completed, and then as part of the second course of action is when the automation kicks in. And the last one, which is kind of important for you if you're worried about data visibility and then security, which is one of my favorite topic. When it comes to regular triggers, it goes through the user content, whereas when it comes to asynchronous triggers, it goes through the automation process, user content. And I also want to give you some of the use cases that when you can use CDC triggers and when not to use CDC triggers. And again, these are all not the facts. This is purely based on our experience and our thoughts. So the first one, if you're going through some of the data replication scenarios, going back to the case study for banking information and banking sector, there are certain kind of information that needs to be replicated for the future references. So asynchronous trigger would be a perfect example. Then number two, business process automation, and this is where it gets trickier. If you have one of the complex business automation scenario, and if you couldn't able to handle it using traditional triggers, and it's consuming a lot of your resources, then you can able to split and make some kind of automation as part of your transactional tables and other set of actions under asynchronous trigger. You can still able to break it. Then number three, kick off long running process, which is kind of like baked into the second part. So if there is anything which is taking way more time and if you're getting more timeout errors, rather than worrying about making it more precise and make it more efficient, you can able to split it and could able to achieve it in a much easier and a better way. Some of the scenarios where I want you to think before you try CDC triggers is number one, if you're thinking of validating anything before you complete the transaction, and if you want to do some kind of custom user validation, don't think of CDC triggers. Like, you will not going to get any of the responses from an UI standpoint. Then number two, the CDC triggers are primarily focused on making system to system communication, not for system to end user communication. So if you're thinking of making any email communications or transactions, like, make sure you understand it, you test it before you apply any of those as part of this. So those are all the things I think I have, and you can take a photo or screenshot of this QR code, and this QR code is going to take to the PDF version of this entire presentation. Thank you very much for taking your time and learning asynchronous CDC triggers with me.